Hey, friends, welcome back to the Old Fashioned On Purpose podcast. This season, we are diving into some topics that I have been really interested in lately as I've been researching my own book and doing a lot of reading. And I'm really excited about today's topic because I think we've talked about it here and there, maybe on the periphery of some of our other subjects over the years here on the podcast. But today, we get to dive in deep to some of the mental health aspects of this old fashioned lifestyle that we all love. I think we all know that there's lots of physical benefits. We feel better when we're moving our bodies and we're getting exercise and fresh air. But what about our brain and how is it responding to all of these unique tasks and projects that we do as old fashioned on purpose people? So I am excited to have the expert on the topic joining me today. I have Dr. Kelly Lambert, who is a behavioral neuroscientist interested in experience based neuroplasticity, which we'll dive into what all that means here in a minute. In addition to being a professor of behavioral neuroscience, she has published more than 70 research articles, 2 textbooks, and 3 mainstream books. So, welcome, Dr. Lambert.
Nice to be here, Jill.
So I have a lot of questions for you, but to kick us off, could you just kind of give us a little bit of a background of what is neuroplasticity? I mean, maybe for the layperson, how would you define that? Since that is really your area of expertise.
Right. So I think it's the message of neuroplasticity is quite inspirational because it reminds us that our brains are not carved in stone. They're always changing. So neuroplasticity responds to or refers to the notion that our brains, so we have these cells in our brains called neurons. We have about 86 billion. I question how many I have sometimes, but we're supposed to have that many. And they're all making connections. And the way that we're able to function is that there are proper, appropriate, sufficient cells and connections, networks, and such. So those connections are influenced by our experiences. So we may produce some new cells, and it's a little different in I work a lot with rats and laboratory animals. So we can produce new cells throughout our lifetime, more when we're younger, when we're humans, but we still produce them. And these neurons have extensions where they grab onto other neurons. We call these synapses. And so our experiences influence the growth of these neurons and the connections they make. So our brains are indeed plastic in the sense they're malleable, they change, and they change in response to the demands in our environment, our training, our behavior, interactions with environment, and our thoughts as well. So neuroplasticity is how our brain changes in response to our experiences.
That is really exciting. Is that? I mean, I've heard of it before, but is it a fairly new I'm going to say discovery, or have we known that for a long time, or is this something that science is just kind of now starting to poke around
Really
into?
good question, Jill. We had people speculated that the brain changed, certainly even in the 18th century. But before we had the technology with neuroscience, it was hard to see exactly what the mechanisms were. But when I was an undergraduate at Samford University in Birmingham, Alabama, you can probably hear my southern accent still, even though I've been in Virginia a while.
Yeah.
One of the most exciting studies I ever ran across, and it put me in this field, and we're doing more of this research now, is about enriched environments. And my professor described how a group of scientists at UC Berkeley put rats in kind of a Disneyland environment. So they went from these boring cages where they had everything they needed as far as food, water, temperature control, no predators. So life was safe, but it was boring. And then they put them in this larger cage where they could interact with each other. They could dig. They could move things around. They gave them new stimuli or new objects to explore. And so that was interesting. And they waited, I think some early studies, maybe 2 months. And then they looked at their brains and this outside area that is dense in these neurons, these cells, and that can change. All the cells can change, but they noticed that it was thicker and their brains were a little heavier. And it just seemed almost like magic. I'm a scientist, but it's interesting. It's like pulling a rabbit out of a hat, that you could pull a brain out of an animal that had been changed based on its environment. So that was a little bit neuroscientists were like, what? I thought that we were born with the brains we were going to have, and we're kind of stuck with them. And so it took a while for the neuroscientists' brains to change enough to accept this,
Interesting.
what they
Yeah.
were seeing, which is kind of ironic. And so since that was the 1960s where it really started to see these studies come out of Berkeley, and now it's a very popular area, and we know that we didn't think new neurons could be produced until about in humans and other mammals 20, 30 years ago. We thought, oh, you're born with all the neurons, but they can make new connections. But now we know from interesting studies that there's this process called neurogenesis, and it's the production of new neurons. So that happens more in humans during childhood. It's still kind of controversial how much that happens throughout. There's only so many cells that can fit inside our brain and in our skull. So there has to be some method of moving them out. You can't just keep producing new ones. So the brain seems to have figured that out. We're still trying to figure that out. Is it even worthwhile to have new brains, new neurons, because our networks are already established? But there's some mix, and we're still trying to figure out those clues. So your question about how long, the last 20 or 30 years, there's been a lot of excitement about neuroplasticity.
That's really recent. Like relatively very
In the
very recent.
bigger
Yeah.
scheme of things.
Okay.
And I can tell you about our interesting take on the enriched environments that you may be interested in.
Yes, I was actually that was one of my
Yeah.
questions. I was like, how do we create that? Give me more info on that because I'm very interested in that.
So if you read most of the scientific literature, they would take these rats and give them what I would say artificial toys, almost like Happy Meal little things, mirrors, plastic ladders. Um, and so I work mostly with undergraduate students, which is great because they have younger brains and they can keep my ideas from being so fixed and carved in stone. And so 15 years ago or so, some of my students, they said, well, we were talking about why are all these studies using artificial stimuli, these plasticky things? And
Yeah.
I wonder what would happen if you put natural, a little bit more natural stimuli objects. So instead of a plastic cat ball, we may put a rock or a pine cone, or instead of still kind of natural, but we put corn cob bedding for them as part of their substrate for the bedding. What if we put dirt? Rats love dirt. It just kicks up all this activity. So we started to match each new object or stimulus, artificial and natural. So we call them our city rats and our country rats. To see now, part of the enriched environment is that you're adding new things. So we still added new things, but we kept it with more of a natural versus artificial. If we had a plastic ladder in the city rats, we used a stick maybe and so I think I interviewed the researcher Marian Diamond, who was on that initial study in 1960, and she recently died last several years, but she was a wonderful neuroanatomist. And I asked her, I said, why did you always use the artificial? And she said, that's a good question that they also thought about. So they had put some rats outside in the days where you could do that. And she didn't test it too formally, but what they found was that the brains were heavier in the outside, more natural environment. So that prompted us. And so what we have found is we don't see many differences in what we call cognition, learning ability, but emotional resilience. So we give the rats a challenge like, let's see if you can swim in this big tank. Our naturally enriched animals are bolder. They're more likely, I love this response, they'll dive. They've never been in water before, but they're more likely to dive under to explore, like, I'm getting the heck out of here, I'm going to check it out. And then when we look at their stress hormones, which is an important part of our well-being, stress is a big part of all of our lives, and being able to cope with that effectively is real important. So they seem to be able to cope with stress more effectively. And the idea behind that, Jill, is that our brains, if our ancestors had different experiences with the world around us. And so through evolution, we were selected, animals were selected to be successful in certain environments. So rats, they burrow, they dig. They're certainly outside. They were not selected to be in a plastic cage in a laboratory. And
Yeah.
in some
Yeah.
ways, I'm very critical of my work and others that look at laboratory rodents, but it's something that I was told to do, but I'm getting into wild rats now, so that's another fun
Yeah.
topic.
Yeah.
But if we look at the environment that animals evolved to specialize in, that means the brain is probably going to be more responsive to it and more engaged. And so we think that's what's going on with our naturally enriched animals. It's still good novelty in any form. Um, well, as long as it's safe, I guess,
Sure.
is good. So our city rats and living in the city and culture and you're exposed to a lot of things, that's great. But there may be something that is specifically nurturing, protective about being in the natural environment that our ancestors evolved in and were
Yes.
successful in.
Yes. And I think it's fascinating that even with the rats, that's evident. And I know many of the homesteaders listening to this, we all know we feel better. I mean, all humans know we feel better when we're outside in nature and when we're in our gardens, when we're going for a walk in the woods. But I love that there is so much science and data that's is quantifying that. It's not just, oh, it's in my head or I just think I feel more relaxed. Like it's actually, we need it. It's really, really important.
Right. I agree. I use this term behavior pharmaceuticals instead of pharmaceuticals, where we can
Yes.
change our neurochemistry with our behavior and our environment. I call it that because it makes it sound like it could be medicinal and things that are
Yeah.
non-pharmacological because you're not going to make money. There's so much money
Right.
to be made with
Right.
pharmaceuticals. So I'm trying to give it a little bit
Yes.
more prestige or something. But yeah, and there's actually human studies. We don't have to just talk about rats, but
Yeah.
in Sweden, where they keep very accurate medical records from the birth to death, um, something about 3 years ago, a study came out where people who had like green space, trees and such in their yards growing up, that variable, were about half
Hmm.
as likely to have experienced a psychiatric illness in their lifetime, and that is huge. I mean,
Wow.
if there was some
That's huge.
drug or medical procedure that would say this will decrease your chances of having psychiatric illness by half, we would want to bottle it and someone would want to make a lot of money from that. So, and
Yes.
then there's a plant in a hospital room or a kid's room where the window looks out to the green space. Lots of evidence, even with humans, that is important for our well-being.
Absolutely. Yes. Yes. I love that it's proven now that we know
Yeah,
more of the
got
mechanism
some
instead of
data
just,
behind it.
yeah, good data, good data. And that's it kind of brings me to my next question, which is why or how I originally found your work. I was researching for a new book of mine, and one of the things that kept coming up in all different avenues of research is I saw all these statistics for rates of depression in modern cultures. And it's talked about a lot. It feels like it's kind of one of those things. We're more depressed or we're more anxious or whatever, and then people would go along to give their cures or whatever for it. But from your perspective, because I know you've written books on depression and you've done a lot of research on that, is it true that we are more depressed as a culture than we were in decades or centuries past, or is that just kind of a guess?
I lean towards saying yes. The statistics of people who, rates of depression seem to be on the rise, especially as we've gone through COVID and people have encountered a lot of loss. They've been isolated. So, yeah, so depression, I can talk a lot. I'm very passionate and frustrated with where we are with depression.
Yeah.
So, if we look at other illnesses such as diabetes, cancer, AIDS, um, and look across the last several decades, where we've made progress. People are less likely to die. We haven't cured those, but they're less likely
Hmm.
to die from cancer than they were 20 years ago or AIDS. So something we're doing as far as the medication, the treatment seems to be working. We can always do better. Um, Depression that's not the case. We still have a lot of money has gone into research. Antidepressants are a multi-billion dollar industry, but the rates of depression have not gone down. And the extreme end of depression is death by suicide. And those rates,
Yeah.
they're very scary right now, especially in young adults going through in this time of COVID, but they've never really dipped. So it's it's a mystery to me. If we know what's going on, if we have medication, it seems like incident rates should decrease. Now, some people, I like to look at everybody's, be open minded. You could say, well, we're more aware of depression, so people are now that
Sure.
it's a thing and we know what it is. People, it's just because more people are reporting, but maybe it's not different than what it was
Yeah.
before. So, but if we just look at rates, they are not decreasing like other illnesses are, and depression is an illness. It's something is going on with the brain.
Right.
Um, so that got me on a path that you may have read about to try to look at it a different way. And I can talk about that journey. I don't know
Yes. Yeah.
and how
I
that
would
led.
love. I would love that. Yeah.
Yeah. So I was writing a textbook, clinical neuroscience, and being a good student of the literature and doing what I'm supposed to do, reading all the studies. What are the treatments for depression? And it just was mind boggling to me how really none of them were working. And the premise behind antidepressants. Now, I want to have state a disclaimer. I am not a clinician, and if anyone is on medication, they should be consulting with their doctor about every step of the way, and shouldn't hear something that makes them think about it and just stop cold turkey. That would never be
Sure.
what I'm
Yes.
saying. But I think we could all be good consumers and question what we're doing. So
Yes.
I was
Amen.
just frustrated with the literature that it's not helping depression. And then when you look at antidepressants are based on the premise that we have a chemical imbalance of serotonin. Serotonin is incredibly important for mood regulation, but also sexual behavior and hunger and aggression. It has a lot of different functions. And a couple of maybe a month ago, so, but recently there was a big study, what we call a
I saw
meta
that.
analysis. Yes,
Yes.
and clarifying that it's not clear that we have any imbalance, and certainly that there's not a deficit in serotonin, because antidepressants increase that activity. So it makes you think, oh, if we take a drug that increases the activity of serotonin, we must have a deficit. But if eating your grandmother's chicken noodle soup makes you feel better, we don't think that we have a chicken noodle soup deficit. There's something
Sure.
about eating it and the relationship and memories or whatever, that expectations that make us feel better. So even before that, years before the meta-analysis came out, the literature still was not suggesting that there was a clear imbalance. But I will say that the drugs help some people some of the time, but the
Mm.
rates are not much higher than a placebo effect. There are lots of side effects that go with these drugs. So you always, as a
Yeah.
patient, have to do a cost benefit analysis, and should always question, how do I know if these are working? And when do I know when I can stop taking these? Because the drug companies would love for us to take them our entire lives. So anyway, I was
Yes.
frustrated with that. So if you're frustrated, my mom always said, don't, unless you have something informative to say, you shouldn't be criticizing. So I wondered what I could do in my little lab with undergraduate students and rats that may contribute to this. So I went back to the drawing board. One of the signature characteristics or symptoms of depression is sadness. It's a lack of feeling joy and pleasure. So if you look at the brain area that is most often associated with pleasure and is hijacked with drugs of abuse and such,
Mm.
but is engaged when we eat our chocolate cake and with sexual behavior and friendship and achievement, getting technical, it's called the nucleus accumbens. And so this brain area, when I looked at the neuroanatomy, going back to the brain's drawing board, it has connections to movement. So this big area in the middle of our brain called the striatum, that's affected when a person has Parkinson's disease or Huntington's disease, neurodegenerative movement disorder. the nucleus accumbens, part of it, that inside portion, is going to the striatum. And it also goes to our emotional circuits. But I'm thinking, could movement have been associated with positive feelings with our ancestors?
Yeah.
And then when you look at the brain too, I was trying to look at it from a neutral perspective, and you just look at what has the brain invested in. So much of the brain is devoted to movement. We have this structure hanging off the back of our brain called the cerebellum. Technically means little brain, so it kind of is this little brain, and it is most often associated with motor coordination, balance, kind of movement. Nearly 80% of all of our neurons in the brain are in the cerebellum.
Mm.
80%. That means movement, coordination, balance. All of that was incredible. Nature really invested in that. And then I just described those big areas in the middle of the brain, the striatum, involved in movement. And then as we go out to the cortex of our brain, that outer covering like bark on a tree, we have big strip, a motor cortex. So if you had to look at like real estate, you would say movement is incredibly important for the brain. Uh, and so then it makes you think, well, if pleasure, if that area is associated with movement and so much of our brain is devoted to movement, how is our current practice of what we're doing right now, sitting in a chair right
Yes.
now,
Yep.
uh,
Yep.
being, we feel like we work hard, but I may not get off my rear
Yeah.
end.
Yes.
And so my movement is very restricted. And I'm also going back to that accumbent, that nucleus, that pleasure area that's related to movement. Um, Maybe the connection is that it registers satisfaction when you've moved and done something, produced something that is valuable. So it made me think
Yes.
about physical effort in a real different way, and that it's important and critical for our mental health, our neural health. That neuroplasticity that I was talking about and the production of new neurons, there's nothing you can do that will produce more new neurons in the animal models. And so we're still thinking about the humans. But
Mm-hmm.
put rats in a running wheel. Running activity
Ah.
is so
Okay.
incredibly important for kicking up neuroplasticity. Maybe the brain thinks it's going somewhere and it's going to need the support of
Yeah.
the neurons to do something new. So I was all about movement after going to the literature, being a student of the literature, and I wanted to develop a model with the rodents so I could look at it a little more closely. So thinking about my grandparents who are always loved their garden. I know you love that, Jill.
Yeah.
And
Yeah.
it's not going back too many generations. I know that you're celebrating this life for that lifestyle for all the best reasons. I recall my grandparents in Talladega, Alabama, who were so privileged to have their garden, and in the winter when my grandmother would bring out the canned tomatoes and
Mm-hmm.
the corn that she froze, and the memory that she planted that, and she sat on her front
Yes.
porch every evening in the summer shucking corn or doing something and then canning. It was a reminder that you have some control in your life,
Yes.
that you produce something that you're eating now. And that has to, if our brain is registering adaptive responses, you're probably getting a dopamine hit like you would rats getting cocaine hit. It's all
Totally.
about this dopamine.
Yes.
Yeah.
Yep.
And I remember my grandmother in Alabama when we used the term, the phrase, bless their hearts or bless your
Mm-hmm.
heart when you're not able to do something that's expected. So if one of her friends couldn't have a garden because she was sick or something, it was always bless her heart, she couldn't have the garden. She was denied that privilege of
Yes.
being able to produce that food. So long story to kind of produce something like that. So my rats, I wanted them to harvest their
Yeah.
food rewards by digging up, and it's not too natural, but dealing with rats here, Fruit Loops. So it's a cereal. It has the word fruit in it, spelled
Yes.
different.
Yes.
So it's something my rats love.
Okay.
And so we would just have mounds of bedding. We would move the mounds around so they would need to look for it. And then they knew that if they found a mound, they could go and dig in that mound and get their Fruit Loop. So we do this for about 6 weeks. And a lot of rat research, you don't train them for very long, but this
Mm,
is long as rat training goes. So we really want to establish this idea of maybe even self-efficacy, which is a big kind of term for a rat, the sense of control over your environment, or that
yes.
you have the ability to solve a problem with this efficacy, sense of control. And we think that a heightened sense of control reduces stress because uncertainty, anxiety, certainly we see higher stress hormones. So we have the group that is trained to dig or harvest their Fruit Loops. This is just 5 or 10 minutes a day. It's not heavy duty training. Our control group, because in science you always need a proper control group, we would put the control group animals, they were matched animal for animal. They were put in the same arena with the same mounds, but we just gave them the same number of Fruit Loops that their buddy,
Mm,
we call it yoked,
yep.
matched buddy, got that day. Now, rats aren't robots. They don't always dig up all of them. They're slower. Sometimes they figure out that, oh, if I just stay in here longer, I can stay, if it takes me longer to get the Fruit Loops, I can stay in here longer. So it would vary how many they would get per day. So we would match that. So we called our rats that were digging up the Fruit Loops are worker rats, and the rats that were merely given their Fruit Loops regardless of their effort, the trust fund rats, just to kind of be cute.
Okay,
But if
sure. Yeah.
I'm wearing my experimental hat, I would say contingent based and non-contingent. Uh, and so we found some of it similar to the enriched environment animals. So that those stress hormones, the profile of our version of uh, their version of cortisol, the stress hormone, and there's another
Hmm.
hormone that is produced in humans by the adrenal gland that sits on top of the kidney. That is the gland that secretes the stress hormones, and it's DHEA. You may have heard about this in health food stores and such.
Yes. Yes.
I'm less of an advocate of going to a health food store, but I'm interested in how we produce it. So, if you have higher rates of DHEA to cortisol, it's correlated with more resilience, such as some studies at Yale looked at special operations soldiers that were trained in all these, handcuff you and throw you in the water and good
Hmm.
luck, see if you
Sure.
can figure this
Yes.
out. Those that had the higher ratios of DHEA to court were better on those resilience tasks. So that effort-based reward training increases that. And in some of our work, it has enhanced neuroplasticity. Um, and their persistence, we give them just a simple little task, not very technologically advanced, but like get a cat ball from the pet
Hmm.
store, put a Fruit Loop in that it can't come out, so it's bigger than the little holes. But the
Yeah.
rat doesn't know. But the rat loves the Fruit Loop and can smell and see the Fruit Loop. But this is a novel object, and some rats are kind of scared of novel objects. So, but the effort, we call it effort-based rewards, that training, because the rewards are based on effort that you've expended. Those rats will work harder before they give up. So there's a
Okay.
literature in psychology about learned helplessness, and it was originally done with dogs where they would do a mild shock and they taught them that they couldn't get out and they would just give up. They wouldn't keep trying to escape. So I like to think of this as learned resilience or learned persistence by having experience of working and seeing a positive result, working and seeing a positive result. You have a little bit more confidence that if they would work harder with that cat ball, even though I tricked them, they really couldn't get it.
Yeah. Sure.
They worked at it harder, and so I think that cognitive expectation and sense of self control and the physiological evidence of lower stress and healthier stress hormones and some physiological evidence of neuroplasticity. Um, this is a what I call a rat model version of cognitive behavioral therapy, and it's
Yes.
changing our physiology and our neurochemistry through our behaviors and expectations. And rats can have expectations too
Yep.
because of associative learning. And more recently, with a grant from the National Institute of Mental Health, I wanted to put this model against the test of some of the more contemporary therapeutic interventions that people are excited about. That I'm concerned about, I'm cautious about, like
Mm-hmm.
psychedelics and ketamine.
Mm-hmm.
Ketamine, I've
Yeah.
had known as a horse tranquilizer, so I'd be a little bit
Yes.
scared to take it.
Yep.
But I want to be, I always want to look at the literature. There is evidence that some people who are given those drugs like ketamine, and this is not something you can go to the drugstore and buy. It has to be
Right.
administered in a hospital setting and have someone watch you the entire time because you could have a bad trip, which again is another kind of point of concern. But when I wanted to see, okay, what are the neuroscientists saying? What is the mechanism of this? And so there's an area of
Yeah.
the brain called the lateral habenula that I've become excited about lately. And it's thought that the lateral habenula is involved in this like a freeze response. Like if you're really scared, rats, if they're scared, like if I put a cat urine odor, they'll freeze to like,
Mm.
what is it before they say, look at me, so it's adaptive to pull back, assess the situation, to not be all jumping around and active. So usually this is in the context of fear and anxiety
Okay.
and you hold back. So this area of the brain is activated when an animal shows that severe stress, anxious response. Ketamine and some of those drugs seem to be relieving that. So the person's not having that fear, deer in the headlights kind of response. So I
Okay.
wondered if effort based reward training could change that. So we've done a couple of studies looking at activity of the lateral habenula, and so, like two studies so far, and we just published one last week, um, showing that the effort based reward training suppresses activity in this lateral habenula as well, and the measures that we're
Wow.
looking at. So, if I can show that this effort based reward, that cognitive behavioral therapy, that a lot of medicinal, they're not so excited about it, but the research
Mm-hmm.
for cognitive behavioral therapy is just very impressive. You don't have side effects. So, if I
Yes.
can show that
Yes.
it's utilizing and hitting some of those neurobiological mechanisms that those drugs that work are doing, I think
Mm-hmm.
it gives these behavioral therapies a little more credibility. So that's just a rodent model. It's
Yeah.
early research, but it's checking boxes that suggest that it's doing some similar things that may be working pharmaceutically for depression. But what it's not, how it's different, is that you don't have the side effects of a drug and the dependence on that drug. So if we can change the neurochemistry in a similar way where it's in real time and under our control, and the brain is seeing this is when I do this, this happens, and when I do that, this doesn't happen. Um,
Yes.
because when we are taking drugs, pharmaceuticals, and I'll just say like an antidepressant chronically,
Yeah.
it's like if our brain, if you have if your car breaks down, you can hire a tow truck to carry you around all the time without fixing or repairing the car. Um,
Yes.
but we don't want that. We want to have the car that is manageable in itself, so and that we can control. So in some ways, I think about some of the antidepressants as that chemical tow truck. So I so I get excited about the possibility of cognitive behavioral therapy or any type of behavioral therapy where we may be able to manipulate, control, influence the brain and its outcomes behaviorally without exogenous or putting medicine into the brain, especially when we don't know that
Yes.
there's a clear deficit or a clear imbalance.
This episode is sponsored by Redmond Agriculture. If you recall from previous episodes, they're the company that produces my absolute favorite salt for baking and cooking. And they just launched something new that I have been dying to tell you about. So, for years, you've heard me talk about soil testing. And it's so crucial for us as home gardeners who are trying to produce food to know what's going on at the soil level. Otherwise, it's really easy to get frustrated and not understand why your yields might be where you need them to be, why some plants are struggling, and so on. Now, the problem with soil tests is that they've been pretty cumbersome to do. You have to find a university that does it locally or mail them off to random places online. There just hasn't been a great option until now. So Redmond's just launched a soil test kit that is designed for people like you and me, homesteaders and home gardeners. And what I'm holding here is a bunch of my printout results, and I have been totally nerding out over this. So it's super easy to do. You get the kit, you send it in the mail, and within 5 or 6 days, you'll have results emailed to you. I discovered things in my test reports that I had no idea. I'm going to go into all the nitty gritty on a future podcast episode, but just for now, I'll tell you a few of the most surprising findings. I discovered my compost pile was low in nitrogen. I discovered my greenhouse was too high in nitrogen. And I discovered why the potting soil that had gave me so much trouble this spring was killing all my plants. So again, I'll go into the details in an upcoming episode. But for now, I want you to have access to the soil kit because gardening season is rapidly coming to a close. And if you've had a rough year, like many folks are reporting that they've had, now is the time to test your soil and figure out what's up. So if you go over to the prairiehomestead.com/soil test, you can use the code HOMESTEAD to save 15% on soil kits or anything else that Redmond has to offer. So I can't wait for you to try this. Knowledge is power, and as gardeners, we can use all of the data that we can get. So now back to our episode. Right. So just to make sure I'm understanding it, like I guess maybe I've always heard it explained on a much less sophisticated in a much less sophisticated way in terms of like, okay, well, you feel good when you can tomatoes because you get a hit of dopamine, which is probably is that true on a very elementary level?
Well, I don't know if
Sort
anyone's
of.
actually ever looked at dopamine
I mean,
in
I'm sure
canning
they have a
tomatoes, but
study.
yeah, that's what I'm
Well,
suggesting. That's what I'm
okay.
suggesting.
Yes.
Yeah.
But it seems like there's a lot more like amazing intricacy also at work. So you might be getting the dopamine, but you're also activating the cycle and you're getting a deeper satisfaction. So it's probably like, it sounds like so much more of like this web of benefits we don't even fully understand. I mean, if you're getting similar effects to ketamine on in an element plus everything else, that's just mind blowing. I mean, it's better than I thought, I guess.
And again, I don't
Better
want
than
to oversell that, but just in our little study,
Sure.
we're finding that a brain area that is affected by ketamine is also affected by this. So you're right. It's more than just an an independent event of, oh, get this dopamine, but that the reason why you may have a hit of dopamine, if we're going to kind of be, is because of your experiences, your past experiences that have led to the associations that this is good or I felt good in the past, and you're looking to the future. When the human brain has this cortex that just is amazing, the number of neurons that we have, more than any other brain on the planet, even compared to the large elephant brain and dolphin brain. So we're making associations with this outer covering of the brain. So as you're canning tomatoes and remembering that this was you had positive experiences in the past, you're also looking to the future and you're thinking about that meal you may have in January or Christmas when the family's together and you say, oh, this tastes like summer, or the spaghetti sauce you're going to make down the line. So that all of that reinforces these networks and these expectations. And we're even starting to look at things like positive expectations in rats. We noticed we have I don't know if you've seen, but kind of science outreach. We started teaching rats to drive cars. It's another thing.
Oh wow, that's awesome. That's
awesome. You can Google Kelly Lambert and driving rats. And see a lot about it. So this is training, and our ancestors weren't driving cars, but we do. But so we have all that research about cognitive training and looking at enriched environments, and those in the enriched environments learn to drive the little rat cars, rodent operated vehicles, ROVs as we call them, faster than those that aren't. But I went to a conference in Scotland in June, and I've just been being in the pandemic, everything's so negative and fear and stress. All of our research is on fear and stress, and I said I need something a little bit more positive. So walking in the lab, and we have this group of female rats that they were on Netflix in June, and they're kind of little rat celebrities, and we don't do studies on them. They just in their enriched environments, and they sing. I'm being anthropomorphic, giving animals emotions, but they show evidence of really enjoying their training because they get Fruit Loops. And so when I walk into the lab, they come up like little puppies. They're jumping on the edge of the cage, and then when we put them in the cars, before we can put them on the floor so they can activate the driving mechanism, they're like revving the engine.
Oh my
And
goodness.
I think they're they have anticipation of something good. And
Okay.
it's so interesting to think of what's going on in the brain when you're thinking about something good. And so I like little acronyms. So uh, I told the students, I said, we're going to kind of drop everything and look at this unpredictable, we call it unpredictable positive expectation response. And that's uppers, right? So we have our
Yeah. Okay.
behavioral uppers without it, just one P. And so we started training them where they would have to wait and look forward to stimulate, like they love Fruit Loops, but we put a little Lego block in there and they know they have to wait 15 minutes before they get their Fruit Loops. And they carry the block around and they're jumping around. And
Okay.
we don't study this often enough. It's like a child at a birthday party when it gets a present, just that jumping around when you can't control your emotions.
Mm,
And it reminds us how movement is related. So I say that we're starting to look at these anticipation and positive to see if we can train in these positive emotional responses in rats to see what's going on there. And I think of the environment as a way to sculpt our brains. And if we haven't had experiences with positive emotions, it may be difficult to experience them. It may be something
mm,
learned. It may be hard to just say, well, get over it, be happy. If we haven't been happy in our lives, we haven't had things to look forward to, that may relate to depression as well. And anticipation is incredible
yes.
for the brain, just like
Yes.
work. So if we go back to the rats, we know that if they press a bar to get cocaine, that influences the dopamine because cocaine influences dopamine in the
Mm,
brain. But the highest change in dopamine is not when they hit the bar to actually get the drug, it's when they approach the bar in
uh,
anticipation of getting that drug.
yes.
So we need to really think about anticipation and looking forward to things as something that's important for healthy brains as well. And in our society where everything is at the this press a button to get this yesterday, today,
Yeah.
Amazon Prime within a day. Um, our ancestors had to wait for harvest, for building, for things to come around. And I worry that we don't have enough anticipation for our brains as well. So that's something new that we're kind of working
Yes.
on.
I agree. I've noticed that myself too. Sometimes I've even thought, well, man, I had more fun thinking about this happening than actually doing
Uh-huh.
it. It was, it was, yeah, I've noticed that several
Yeah,
times.
planning
That's
a
fascinating.
vacation is
Yeah,
the real vacations rarely live up to the anticipation of a
exactly.
vacation.
Exactly. But it's fun to think about it. Yeah, it's fun to think about it.
Yeah, it's important, I think, for
Yeah.
children. I would tell my girls, they're grown up now, but not only is it important to have your effort based rewards, cleaning your room, but to wait, to look forward to things and not have them happen, tomorrow.
Yes.
So
Yes.
trying, those are important.
Yes. And man, our culture, it's hard with our phones. I mean, everything is so instant. So, I mean,
Yes,
I even catch myself, the microwave's taking 15 seconds and it feels like an eternity. It's
I know.
just, we're so
Yeah, I
used
say
to
these things,
everything.
but
Like,
I'm
yeah,
guilty of it
I
all.
know. Yeah.
Oh
We
my
all, I
God,
think we all
the
are.
internet
Yeah.
went out at our university today for 15 minutes. I was like, oh my gosh,
Yes.
what are we
An
going to do?
eternity.
So,
It's an eternity.
um,
Yeah.
yeah, yeah, yeah.
Yeah. So with the movement, I was thinking about what you said. So the effort-based reward circuit or systems in our brain, um, mo- we need movement to keep that kind of flowing. I know I'm way kind of dumbing this down, but just
No, no,
in
you're
how
good.
I'm
Yeah,
thinking
yeah,
about it.
yeah,
So
yeah.
is it just movement like running or lifting weights or things like that? Or would, working with our hands or creating outside of touching a screen or tapping a keyboard, would that trigger that as well?
Yeah, that's a really good question, and I should have clarified that. So both are important, but I think exercise is different than what I'm describing as these effort-based rewards, which would be similar
Okay.
to working or hobbies or something. So
Mm-hmm.
exercise, I mentioned that running was good for neurogenesis. So when we are physically active, it increases the blood flow to the brain, and that delivers glucose and oxygen, which are that's their food for the brain. So by being physically active, running, walking fast, cleaning the house, whatever,
Hmm.
and you can increase the nutrients for the brain, that's good. So these effort-based rewards, that's a little bit more cognitive, and I think would be related. They're both important.
Sure.
There's research suggesting that exercise can help pick up neuroplasticity and help with depression on the same similar levels as antidepressants
Yes.
and maybe even more. Um, but effort-based rewards, that's getting more into expectancy, anticipation, sense of control, self-efficacy. So I think that it's different. I don't think, at least in my rat work, they're not working hard enough to get the increased glucose, really a
Sure.
lot of blood flow like if they're running. But they're learning associations between their effort and the reward that will make them, I think, more likely to persist. And our data suggest it with these animals in this task, they'll persist longer before giving up.
Okay.
And all that I think is important. We learn a lot through failure
Yeah.
and persisting and learning from what didn't work and did work and what is working. And we're also finding that in that last grant, looking at the cognition, the trained animals, the effort based rewards, they were more likely to notice a change in a pattern. We call it pattern separation. So they seem to be more in tune with looking around the environment because they were looking for those mounds. And if you found things in the environment, they could trigger a reward. And I haven't talked about the dark side of neuroplasticity, but through trauma and stress and all that can
Sure.
change the brain as well. So we've been talking about adaptive. So if you're used to looking around and seeing a mound and, oh, that's a Fruit Loop, you may be more sensitive to that. And
Mm.
that's important for survival, that we notice maybe when our boss is changing his or her tune and maybe we need to be looking for a new job, or the weather is different, or there's a pattern in your child's behavior. We need to notice all of this. And we have some preliminary evidence that through this training, it makes them more aware of their environment and how the environment
Yeah.
may have advantages. And there's an old literature about behavioral affordances and how we may figure out how we can gain things from the environment. And uh, Jim Gibson, a psychologist, called those affordances. So the more we interact with the environment, a perfect example would be children in their play. The more they interact, they
Mm.
know how hard you can hit someone, what kind of limb you can climb out on before it breaks, uh, how digging, just all this interactions with the environment, physical environment and social environment. This gives them more affordances. They know in the future how far they can push it and what they can do. Education is like that. I'm in education, being a
Yes.
college professor, but the more we're exposed to, the more we know about what we can gain from our environment, what we should approach and what we should avoid. So we need to be in tune with our environment. That's what our brain evolved to do, to figure out
Hmm.
how to work the environment, to benefit from the environment, and have positive interactions with people. We're very much a social species. And we learn, if we have collective brains, it's so much better than just one brain. And so
Yes.
isolation has lots of negative impacts there.
Definitely.
So the rats have
I'm just
taken me
hearing.
on
Yeah.
some very deep journeys.
The rats are amazing. Like I never knew rats had so much to do with homesteading because I'm
See,
just seeing
yeah,
all these
they're,
lessons just are like
they're
amazing
confirming
crossover.
everything you kind of thought you
Yeah.
knew. Yeah, but it's
Yeah.
good to
Even
know.
yeah.
Some people may say, "Well, we didn't. Jill already knew that. What are you bringing to the table?" But it is good to know that there are biological mechanisms,
Yes.
especially if we're going to try to intervene and treat and think about therapies with this. And what I want to do is
Absolutely.
elevate those behavioral, those lifestyle approaches, and claim see if they're just as important as other approaches. And the Quakers centuries ago, early in our country, they um, for people who had mental illnesses, their way of treating them was to bring them to this very nice, enriched kind of environment where people they would get up
Yes.
and get dressed and have sewing lessons and hear lectures and listen to music and garden and do all of this. And that makes sense in the light of effort-based rewards. And the data
Absolutely.
collection was different then, but it seemed like people were more likely to be able to go on with their lives and be able and not be on disability. And even when maybe people are taking medication. There's unacceptably high rates of people who continue to be on, not be able to go back to work and be on
Yeah,
some form of disability. And it would be great if we could push them a little further so that they could feel good about, their independence in that way. So maybe we've gone
absolutely.
backwards. I don't know. Or we're coming full circle,
I think
but
it's
we
full
need to do
circle and I
better.
love it. Yes, I agree. And I feel like that's why I'm so interested in this. And I mean, I've been homesteading for 12 years. I'm very familiar with the lifestyle, but lately I've been like,
It's
I need the
wonderful.
deeper reasoning behind it because for a decade I've had people kind of pat me on the head and go, "That's cute. I'm glad that you have that as a hobby." And I'm like, "Okay, cool. I know it's not for everyone, but I'm like, you know, I'm not going to say it's a cure all by any means, but I think there's way more to this that it could be used in a very healthy, prescriptive way for people in all sorts of aspects, whether it's, eating better food or getting your hands in the dirt or creating things to get the effort based rewards happening. So that's why I'm just so excited about it. I know it,
I
but
agree,
now
Jill.
that
You're
we
you're
get those
living you're
pieces,
living
yeah,
more of the life that I'm just talking about, and
yeah,
so I envy that, and I respect that your brain is probably much healthier than mine because you're engaged in more of these natural behaviors. But just knowing
yeah,
too the education part and being able to pick up that, okay, I really like the social media, but like me, I
yeah,
don't enjoy cleaning my house, but I'm not going to pay
sure,
someone to do it because I know that my brain needs to do that instead of doing the
yes,
writing and sitting down
yes,
and knowing why cooking a meal. And not only do you have the effort-based rewards of providing that meal, but if you're doing it for other people, that's a different level of social,
yes,
rewards. So we have to be careful about our society where we have increased
hmm,
stress, so we're more aware of everything that's going on in the world that is worrisome. And we are quick, I think, in the cities. Maybe it's easier. I don't know. The social isolation, we need to be careful that we can do
yes,
that
absolutely.
in the country too. But
Anyone could
we
do,
need
yeah,
each
yeah,
other.
yeah,
Yeah, we need each other, and we need these reminders. So I'm not saying that one type of lifestyle or environment is better than others, but we should have combinations and elements of these healthy um,
yes,
ingredients for our
absolutely,
recipe for life if we want to have a cooking
yes,
analogy. So all this is important, and we're not islands. Our brains need stimulation from each other and the environment and novelty. And travel is really wonderful. It's new experiences as well. So that's another kind of lifestyle when it's safe and it's something new that you can look
hmm,
forward to, and exposing the brain to something new. That's something that we've been interested in as well. So there are a lot of behavioral approaches to mental health that we need to engage in maybe before we take that next step to pharmaceutical or some other type of mental health. But again, that should all be
yes,
just make that decision and
sure,
under the supervision of a qualified clinician or doctor,
yes,
psychologist, psychiatrist. So this is just
absolutely.
what my rats are telling me. So
We're just talking, yeah, just
these
talking
are
about
the
rats today,
prescriptions from the
just the
rats,
rats, yes.
the
Um,
rats and
I
Jill.
the rats and Jill, we're buddies now, so.
Yeah.
um, I did have one kind of. I've been thinking about this for a while, and I've never been able to talk to a neuroscientist about it. So I would love to ask you this
Uh-huh,
question. Um,
uh-huh.
so forever, and I don't even know if this is a thing. I just hear it a lot parroted in different books about personal development books, but they talk a lot about the lizard brain or the ancient part of your brain that tries to kind of talk you out of doing harder things. It's all about just survival and being comfortable, and so you hear a lot of self-help gurus talk about pushing back against the lizard brain. So I am holding that idea here, and then I'm also thinking, okay, but I know there's the effort-driven rewards part of my brain. It's my brain wants to reward me for moving and doing positive activities. How
Mhm.
do those two exist, or do they? Are they? Is the other part even real? Like, how does that work out?
Yeah, you bring up interesting research that was presented or introduced by Paul McLean, and I was able to interview him for one of my books earlier on, and he used that as an analogy to think. So I was just lecturing to my students. So you can kind of think of our brains having a hindbrain area and a midbrain and this forebrain area. So part of our brain does want to do the easy thing, Jill. I mean, it's not that we
Mm-hmm.
have a lizard brain, but
Sure.
lizards and reptiles, their brainstem is similar to ours. So, and that's just involved in very basic functioning, muscle
Mm-hmm.
control, tone, and glandular secretions, and being awake. Um, but we have a more advanced cortex, midbrain and forebrain, as we call that. So we are experiencing life differently than those reptiles. And even though sometimes we want to do the easy thing, our prefrontal cortex and our cortex is trying to get us to do the right thing. So if we can figure out what the right thing is, and that is controversial, and we have biases there, but we have inherited what I call this brain is an embarrassment of riches that allow us to think about the right thing. Um, so it doesn't mean that we're always going to do the right thing or that we're going to avoid the easy thing. But we have the equipment to think about things more. And as we think about things more, the payoffs can be really greater, and we may have more security, and we also have more worry. We're not too sure how to handle this piece of equipment that we have, and there are more opportunities for things to go wrong. And I think that's where mental illness and schizophrenia and some of these things happen, because especially during adolescence, it's different layers of maturation. But on a positive side, we have a lot more to work with than those lizards. And we're not just reflexive. We see something and we kill it or we run. We still, when we need those survival, when we need to run, when we need to fight, the fight or flight, but we can impose um, more thought into this with our decision making. So if we can just figure out a way to make it work for us, is that's the challenge. And sometimes it may be reinforcing to do something easy, to just eat that chocolate cake all day or to watch Netflix. But our brains are built so that usually after a while that's not going to be very rewarding and fulfilling. And if it is, that means something's probably wrong. That thinking about things that it never worked out. So we need to rework those networks. And through neuroplasticity, and that's where we started, there's nothing in the data to suggest that it's ever too late to rewire some of these networks through training, through therapy, behavioral cognitive therapy, and even through electrical stimulation or drugs or surgery or stuff. But that there are many ways that we can change our brains. So we have this embarrassment of riches with this rich neuronal cortex. And so Paul McLean, he before he died, he told me that he regretted talking about the lizard brain because it maybe made people think, oh, well, I've got this lizard brain and it's easier for me to do that. It was just a way for him to say we share some brain qualities with other animals, reptiles, and birds, but ours are also different. And when he talked about the different part, he talked about primates and his favorite, one of his favorite behaviors, which is also something we've looked at in the lab that we haven't talked about, and that's maternal behavior and being a parent and taking care of another person, or maybe it's a dog or something, but that brings on another level of brain engagement. And I've never seen a lizard pushing a stroller. They kind of have drive-by parenting. They lay the eggs, the turtles, and then the little turtles have to find their way to see. There may be some exceptions, but when a mammal and the mammary glands figured out a way to feed its offspring and take care of offspring and nurture, that developed a brain. It took a fancy brain to do that. And I think parenting and nurturing may be one of the most impressive things, caring for another person, that a mammalian brain can do. So caring for one another is important. So that's kind of where Paul McLean came from. He used it as a teaching, but he was impressed with the forebrain and what it meant for humans and mammals and what the potential is. So, a good question. This has been fun. This is what I'm here for, to share some of our stories. So good luck with everything, Jill. Bye.